So my name is Brian. We are a seed stage venture capital across the built environment and startups, as well as two of the winners of our AEC RE partnered with the AEC Hackathon and cross promoting our two events. And want to thank you guys for giving these two awesome technology startups an opportunity to present to your audience what they've been working on and what they're building. So I will stop talking because I don't have that much interesting stuff to say, and let our first startup go ahead and start presenting. The first company is going to be Aaron. They're building a B2B SaaS platform for civil infrastructure asset management and to assess and manage infrastructure using computer vision, machine learning, and civil engineering. Their goal is to minimize the risk of infrastructure failure and to optimize infrastructure spending across the globe. So we're going to have a 20-minute presentation, and then we'll leave 10 minutes of Q&A, and then we'll introduce Creo as our next presenter. But I'll let Ali go ahead and take it off and start presenting. So Ali, the floor is yours.
Thank you so much. So thank you so much, everybody. It's great to be here. Let me just go ahead and share my screen. Can you guys all see my screen?
Yeah.
Perfect. Okay, so it's great to be here, guys. As Brian mentioned, we are Aaron, and I'm gonna, in the next 10 to 20 minutes, I'm gonna talk about our company and what we're doing, and hopefully at the end of it, we can jump into an interesting Q&A. So we can all agree that civil infrastructure provides the foundation of our society to operate and thrive. But unfortunately, the state of civil infrastructure around the globe is crumbling and is in very, very bad shape. US regulations requires annual assessment of all the 600,000 bridges that we have in the country. Still, 56,000 of those bridges are structurally deficient, with the most famous one being the Brooklyn Bridge here in New York. On a daily basis, more than 200 million people cross bridges at risk, and shockingly, there's a bridge failure once every 3 days. What you see in here is one of these famous failures in Minneapolis, which cost hundreds of millions of dollars and injured hundreds of people. Current methods of inspection, assessment, and management of infrastructure is precarious and outdated. Engineers have to walk, climb, and use a snooper truck to assess miles and miles of infrastructure and use their naked eyes to detect damages and take notes on a piece of paper. Then they have to go back in the office and go through decades of assessment reports and compare it with their field notes to see if the asset is deteriorating or not. These poor and insufficient information feeds the maintenance plans, and as a result of it, trillions of dollars of infrastructure budget are going to waste and people are getting killed. This problem is hitting the pockets of asset owners, engineering firms, and insurance companies. I'm Ali, CEO of Aaron. We are bringing our patented technology to tackle this problem. We are building a business-to-business software-as-a-service civil infrastructure management platform to assess and manage infrastructure using machine learning, computer vision, and civil engineering. In a nutshell, we are building a digital health record of the asset, a digital health record. Our goal is to minimize the risk of failure while optimize the spending across the asset portfolio. So let me walk you through how our product actually works. First, our software aggregates data that the client provides from drones, laser scanners, and other sensors from an asset such as this one, which is a 60-meter long bridge. What you're seeing here is one of our projects in the Netherlands. Second, our platform can automatically build a high-resolution 3D digital twin of the asset with unprecedented accuracy, capable of capturing millimetric details such as this hairline crack that you see on the bottom right-hand side of your screen. What you're seeing in this slide is the screenshots of the 3D model. So let me emphasize, these are not 2D photos. This is an actual, accurate 3D twin of the asset. Third, by using artificial intelligence engine that we have, we are able to detect and quantify severity of different damages such as corrosion and cracks. This is what we can do and apply to different materials and in different assets. And of course, all of it happens in 3D and in the context of the asset. And there's more. We have the capability to quantify changes in time to see how a damage evolves and be able to calculate the rate of deterioration in order to predict future structural changes. In other words, we are providing a historical timeline of the condition of the asset. And finally, actionable insights. Our SaaS platform provides data-driven maintenance and capital allocation plans in order to reduce the risk of failure while optimizing spending across the asset portfolio. And on top of that, being able to extend the service life of the assets that we have in service. In our case, data collection is as easy as taking photos with your iPhone. Everybody can do it, which makes our solution scalable. Now, instead of spending days and weeks in order to conduct structural integrity of the asset, now the engineers can do it within a matter of hours. Now, instead of having access to the asset once every year while they're at the site, now they can get back to it as many times as it's needed from wherever they are around the globe. In our case, our product is sticky because it is mandatory to conduct structural integrity assessment of all these assets within the decades of their service life. And on top of that, and our technology is hard to replicate and is backed by 10 years of R&D and 3 patents that we have. Our technology has been used by our clients to assess the condition of different asset classes across the globe, from bridges in Alaska to dams in Maryland to building facades in New Jersey. In all of these cases, by using our technology, they were able to reduce the time of assessments by up to 50%, saving them tens of thousands of dollars, but more importantly, saving them millions of dollars from costly litigations and poorly spent budgets. So let me walk you through some of the deliverables of our product and what can we do using our technology. So what you're seeing in here is one of our projects that we did in New Jersey, in Atlantic City. In this case, we were working with an engineering firm who were responsible for doing facade inspection. In this specific project, they provided us with a 3-minute video that they captured using drones from one of the towers of the building. And by using that information, we were able to create this highly detailed 3D model. When I put my civil engineering hat on, I mean, the 3D model by itself, it's a very nice looking photo or source of information. But on top of that, what do we need really as an engineer is being able to find the damages. So what you see here are the heat maps overlaid in 3D showing the damages, which was going from blue, no damage, all the way to different shades of green, different levels of damage. In other projects, we were working in New York City. In this case, because of the restrictions around drones, we were not able to use drones. Instead, we used a handheld camera, a 16 megapixel camera, so nothing fancy. We went around the object, took 250 photos, which took us around 35 minutes. By using that information alone, so no blueprints whatsoever, we were able to create this highly detailed 3D twin of the asset. But especially in the post-COVID world, now you have this virtual replica of the asset that you can always get back to it and do visual inspection. But again, talking about data-driven inspection or objective inspection, what you're seeing here is these heat maps of all the damages that we were able to identify and quantify, which in this case, the red colors are showing no damage. And when you go all the way to blue colors, it's showing for example, missing brick on this building facade. One of the important things when it comes down to engineering judgment and being able to understand the health of the asset is not only where are my damages and what's the quantity of them and having the quantification of all of them. It's also where they're located at and what's the pattern of them. So what you're seeing here is working closely with a structural engineering firm who are doing this inspection of a bridge. So what you're seeing in this here is this pre-stressed concrete, a 3D model showing all the hairline cracks, and now these purplish colors showing the identification of all these cracks, which what we call it is generating a crack map, which in this case, it happens automatically. Again, everything in 3D. And what you're seeing here is literally saying, hey, just show me the cracks. Because again, going back to the point that I made, it's important to understand, especially with the cracks, what's the pattern of the cracks. So now you're seeing like on the upper portion of the pier, you have more cracks or more hairline cracks happen in time. And now not only we are able to detect all those cracks in 3D, so everything is in context. There's no like very close up 2D photo of the asset. Everything's in 3D, so you know exactly where you're looking at or which pier you're looking at. And on top of that, each and every crack which is detected in here, we have the quantifications of it, which is like what's the length of it and what's the width of it. And based on that, you're able to say, hey, how severe each and every one of them is. And we are out of this, detection, you're able to create a table showing like you have 10,000 cracks and like what's the quantifications of each and every one of them. When it comes down to beachhead markets, right now our beachhead markets are building facades and bridges, which account for $18 billion in the US. And it's worth emphasizing that our whole goal is to optimize the $3 trillion that we spend on infrastructure on an annual basis. Our team has started in 2019, and currently we have a sales pipeline of $1.1 million across North America and Europe, and we are on track to bring 1,000 assets to our platform in the near future. We are working with major global asset owners and engineering firms, including the Dutch Ministry of Infrastructure and a major global industrial firm who has access to 10% of all the bridges globally. Our team has PhDs in computer vision, machine learning, and civil engineering, and has worked at top-tier consulting engineering and management consulting firms. We are proud to have Cornell Tech Jacobs Institute, Metaprof, and National Science Foundation as our investors and advisors. We are passionate about pushing the boundaries to improve the safety and resiliency of the assets across the globe. I invite all of you guys to join us in our mission. We are Aaron, and thank you so much.
Awesome. Thank you, Ali. I see we've got a few attendees and panelists trickling in. If any of those individuals have any questions, feel free to chime in. I know the Aaron team well, or if Creo, if your team has any questions for him, feel free to ask as well. Paul, nice to see your face. Hope all's going well.
Yeah, I just have one very simple question. Can you, thank you for your presentation. It was really, really interesting. I understand the point and I understand the value. It's really amazing stuff. Yeah, I just wondering if you can explain a bit how you define those corrosion stuff by photos or something like that. Just a little bit more technical explanation, about that, if you can provide it. Yeah.
Absolutely. So one of the key things that we do is, so the portions about like detecting cracks and corrosions and whatnot, all of them is, deep learning and machine learning. So one of the key things that we did was we curated our own data set of all the damages that can happen. And the way that we tackle that in order to, the whole goal was to make a scalable product, was building everything based on material. So for example, in concrete, which is the mostly used material on Earth, you have a finite number of damages that can happen, from cracks to spalling, exposed rebar and whatnot. So that is the way that we created our machine learning tool to be able to, for example, if you have crack on a building facade, or you have a crack on a concrete bridge, we're able to detect those damages. And again, going back to what is the technology behind it, it's all machine learning.
Okay, and what about size of your data set? I would like.
Oh, it's easily in the depends on the material. It's easy, like for each of the materials, it's around like tens of thousands of data sets that we in-house. We gathered them, we labeled them, and it's part of our IP.
Yeah, and it looks like you separated them by material. For example, if you want to check steel joints, connections, you have a specific data set for this, for this stuff, yeah?
Which is going to be like, for example, steel. So you're like, hey, in this scene, I have concrete, I find all the damages in concrete. I also have steel. I'm going to find the damages in steel. I have like timber, do the same thing. So that's the way that you really, because at the end of the day, thinking about scalability, you don't want to say, hey, I can only find damages in bridges. You want to do it for bridges, for dams, for building facades, and et cetera.
Yeah.
So that's why we went with material-based damage detection per se.
And what materials today can you all detect automatically?
So for all the good reasons, we started with concrete. As I mentioned, it's the most used material on Earth. And the second material, and we are able to detect all the damages in concrete. Also, we are able to detect damages in steel. So for example, timber is one of the things that we are working on it as we're speaking, because again, it's not that popular, especially in North America, to have like timber bridges, for example.
Yeah.
Though we did a timber bridge in Alaska, but that's a different story.
Yeah. I have another question. Sorry, it's just a very interesting.
No, we've got plenty of time. Please go for it.
Yeah. So I just because when I was a student, I was working as a inspector or some kind of a person who just checks this stuff, and I just imagine if you can check like let's say structural stuff, not by material. For example, in some building or it's a bridge or something like that, just people simple cut it off like a beam or part of beam just because of some equipment. Can your system understand it? Can your system define it? I mean, it's more about like understanding like a holistic scheme of your structure. It's not about material. It's more about
So if I understand the question well, so some of it is material and material-based kind of damages that can happen. The other kind of damages that we see and we are able to also detect is what we call geometrical changes or geometrical damages. So it's, for example, like talking about a beam on a bridge, like deformation is not something that you can find using machine learning, for example. So on top of the machine learning aspect of our technology, we're using, computational geometry to be able to analyze the 3D models and say, hey, for example, the assumption is that each and every part of the asset should have, if there's any irregularities on the surface, that is a damage. Or if, being able to have, and that's one of the goals here, as I mentioned, a digital health record, being able to have 2 different models at 2 different timestamps and be able to compare them to, for example, see what has changed and for a bending happened or whatnot. So that's one thing. And another thing is the way that we build our technology is to be this source agnostic technology. So while I showed you information about how we process visual information, which mostly focus on, so visual inspection is the mandatory form of inspection, and that's why we tackle that. But on top of that is like, what I showed you now is the visual data processing. But one of the things that we can do is taking information or taking sensor data, showing, for example, subsurface of the asset, to be able to not only see what's happening on the surface, but also subsurface, to be able to get to that holistic view of what's actually happening on the asset. So it's whether things are happening like inside, for example, inside of a concrete deck, you have like delaminations and whatnot. And also on top of the asset, you see like spalling, and being able to see like, based on all of the damages that we found, what is the state of the asset? So to get that holistic view, as you mentioned.
Yeah, I see. Interesting. And also, I have one more question.
Please ask away. We've got plenty of time, like I said. This is great.
When you do a digital twin for a bridge, let's say, you do a digital twin of a current state of a bridge, but probably this bridge was designed in a little bit different way, and probably this bridge already have like some kind of a digital twin. And I mean, in that case, I mean, some concepts which were put to this bridge can be broken during a time, and in that case, it's really difficult to understand like what's wrong with this bridge. Like, do you understand my question?
I mean, can you elaborate a little bit more? Because the thing with like if we talk specifically about bridges, the problem is like, even on some of them, or a good majority of them, we don't even have a blueprint, like let alone a 3D twin or 3D CAD or BIM and all those kind of fancy stuff. So in most cases, like you don't have any of that. So the model that we're generating and the data that we're collecting is going to act like a reference point that, hey, this is like the state in 2020 with all the damages and everything that we detect on it, and saying, hey, based on all of that, this is the rate or this is the severity of the damages. And then from now on, we're really starting to build that digital, health record of the asset through time. One of the other things that because the way that we are classifying the state of the asset is very much using the already in place regulations. So if, for example, you have a rating from before and saying, hey, that bridge is rated 5, we just, for the simplicity, we just go with the example of bridges. Now we run the analysis and now we're saying, hey, it's 4 now. So that's like, hey, it's degraded in time. So that's the way that we use the historic data from the past, though it's not a digital twin, but it is the available data.
And something that might be helpful to clarify is, what you do in BIMs, you're still creating a representation of the real life, right? So you have to draw something based on what you know, and then if that differs, you kind of make a tweak, right? We're not doing that, right? We're really just capturing what reality is. We're not trying to frame it under a model, at least in terms of like the representation.
Yeah.
So we always have access to the reality of it. And if in 6 months that we do another assessment, there's a change, we do not try to update the representation, right? What we're actually doing is like we're measuring, hey, what changed? That implies a given damage, and how will that damage impact the real asset and its life in the future?
Yeah, okay. Yeah, I see. Makes sense.
So something that I actually been meaning to ask is, as far as image quality, when you're creating the digital twins, somebody was asking me this when I was talking to an engineering firm about you all, was underneath the bridge can be very shaded, and on top of the bridge can be sunny. And so what are you all doing when it comes to rendering those images to increase the quality of them, to make sure that that digital twin is really sharp and crisp?
So one of the things is, as we are getting the data from the client, because again, we are not part of the data collection per se. We're not in the business of drones or laser scanning or something like that. Is when we get the data, we run a quality analysis on the images. So if there's any blurry image, can you hear me, guys?
Yes. Yeah.
Because I changed my headphone, that's why I was asking. So when we get the images, what we do is we run a quality analysis, and we assign a number from 0 to 1, 1 being images in good quality, meaning it's not blurry, it's not shaded, the illumination is fine and whatnot. And those are the images that we take in as we are starting to run our analysis on top of that, just to make sure we avoid the whole garbage in, garbage out scenario. So that's one thing. And the other thing is, like, usually when we working with our clients, we have a meeting before the data collection happens, which walk them through like different scenarios and basically a very intuitive tutorial on how to do the data collection on their side. And for example, talking about on the side of the bridge or places that you have these shades, we're saying, hey, first of all, if you want to pick a day, don't pick a sunny day, because in that case you have more shade. Parts of it's going to be super sunny and parts of it's going to be shaded. And on top of that, underneath of it, something which you don't get that much light, using artificial light underneath, and that should be a very homogeneous light that that you use in order to be able to really capture good quality images or videos from different parts of the asset.
That being said, there's guidelines and there's ideals, but then, real life presents you with surprises, and the process, it's designed in a way that we want to make it very simple for people to really use it, right? Like, we in the simplest model is you take pictures with a smartphone, and that is enough to get you the resolution, right? So it's just a balance, right?
And then last question for me, are there any features or new technology pieces that you all are willing to share that you're most excited about that are coming out next and on your product roadmap? And if it's top secret, you don't have to.
No, one of the things is, at the end of the day, for example, working in different kind of assets and asset classes, the owner needs a specific type of, the reporting should be in a very specific manner. So if you're like, hey, working with a consulting firm who is working with like New York State DOT, if you give them a 3D model, the state DOT gonna look at you like, what is this? What should I do with this? So one of the things that we are doing and working on in our product roadmap is how we can go from all this digital twin and creating the models and detecting damages and whatnot in order to, based on all of that information, being able to create a report which is accepted by the authorities, or it's something that they use on a daily basis. So if they need, hey, I need a PDF, we can generate that PDF for them based on all these, like, hey,
dumb it back down.
yeah. I mean, the whole goal is, yes, that's maybe it's simplified. I'm not going to use the dumb it down, but
more PC way of putting it.
But at the end of the day, we want to not only add that objectivity, but add consistency. So because in all of these, inspection and assessment cases, I go out and see something and I'm like, hey, things are good. And maybe you go out and say, actually, that's a pretty bad looking building facade. So even that PDF, like, yes, it's a simplified version, but it's more consistent, and that's why we see it. So in the product aspect of things, I mean, that automatic generation of that report is one of the things that we're working on. As I mentioned in my conversation, like being able to create a table and saying like, hey, these are all the damages. We label each and every one of them, and this is the dimension of them, and this is the global coordinate of that. So you know exactly which part, where on the asset you have that damage. That's what we're working on.
And part of the goal, I think, is, you can come to an industry and say like, hey, this is a big vision. You guys have been doing it wrong. This is the way that you should do it, right? Like, and that's a perfect way to get rejected, right? Like, industries don't think like that, right? So you really,
especially in this conservative industry,
like this way.
Yeah. It's part of these features that we're working on is how do you, yes, there's a vision and there's a big goal, but how do you start and how do you really seamlessly get into that workflow and make it the easiest for the user, right? And eventually you might be able to, like, little by little change that workflows, right? But you have to be you have to be very smooth at the beginning in how do you make it easier for the user to not change workflows that they have been using in the last few decades, right?
That's great. All right. So
just add on to that.
Oh yeah, please, Paul.
So when you're talking about your workflows, what sort of are you following with this data capture?
What sort of what?
Data taxonomy, categorization of the data. Right now, the existing systems that are out there are based upon, at least in the US, with a master, so that Division 3 is concrete. And that then tends to fit into a workflow of understanding where all this data needs to sit instead of making up your own categorization. Are you able to put it into an existing categorization system so it is easier for the workflow?
And I think, to put you an example of, there are different workflows, right? But the very simple example that I was looking that we've been seeing, for example, is, you get people that are, in the best case scenario, are like hanging from a rope, right, and trying to take notes on a building, right? And you might think that it's way easier to take pictures, right, and then get off a pretty dangerous situation and like do it with more comfort and with a lot of data pre-work, right? However, when you go and like realize what people are doing, they say like, hey, it's important for me to be able to touch the building, right? Like to just like knock on it and make sure that the soundproof, right? So while in the medium term, you know, we can give them solutions to that to just make it faster. The truth is you won't take them to that, you won't get them to that second or third step if you don't first address the fact that they are doing it this way. That's how they've been doing it for a while. And, you know, you first have to show it to them in their own terms, right? In like the workflow that they're currently using before you can actually convince them that there might be a different workflow to use. That's
And
kind of what I was referring to.
Yeah, and on top of that, I want to mention, like, Paul, you're talking about like classifications of materials and the damages and like specific guidelines that we have for different kind of asset classes. That is what we're adopting. So for example, just, you know, we are applying this technology to different asset classes, but let's, for this example, let's go with the bridges. So with bridges, we have what we call AASHTO element level, you know, guidelines for bridges, which means, you know, like these are the materials that you have on a bridge, for example, concrete. This is this, and then you go to that, and then there's a table. Reinforced concrete, spalling. If it is between this volume to this volume, or this the dimension, it's fair condition. If it's between this to this is severe condition. So it's that's the table that they have, and that's what they use, and that's what accepted by FHWA, Federal Highway Administration. So we're adopting the same terminology and the same classification. So it's not like when we identify a crack, it's not like, hey, this is how we say this is a severe crack. No, we are using that AASHTO guidelines. So when we say, and we say, hey, we found a crack, it's between like 0.3 millimeter to 0.5 millimeter. That means this is a fine crack. It's not our terminology, it's actually the AASHTO terminology that's accepted by the DOT and Federal Highway Administration. It's the same thing, for example, with buildings, with, you know, Department of Building in New York. That is what we're adopting and, you know, putting in our product. So we don't want to like go there and come up with our terminology. We want to like really be part of their pipeline as seamless as possible.
And in addition to that,
just want to give a quick reminder that our time is limited to at least my time over here is at 7:50. So at some point in time, unless there's somebody else that needs to present, we're good. But if there is somebody else that needs to present, then we should be moving forward. But I will give that 10-minute warning at whatever time it is, 50. Thank you, everyone.
Yeah.
Thank you.
Of course, thank you. So yeah, with that, we can take some of the last questions for you guys, Aaron, at the end if there's time, but I do want to give Maxim and Roberta time to present. So with that, we'll go ahead and introduce Creo Modular. They are a generative design company for software developers, contractors, and manufacturers who are involved in the modular construction. They are looking to save time and money while improving the quality and speed during development feasibility studies. So with that, I'll let you guys go ahead and take off and run through your presentation and capabilities.
Yeah, can you hear me? Is everything fine with sound?
Yep.
Okay, nice. So I will show you guys a very simple presentation about like some problems that we are trying to solve. And also after that, I just will do a quick demo with explanations about which technology and which algorithms we use. Okay, so as Brian said, so Creo Modular is like, you know, it's like a software as a service solution for modular construction market. And we actually allows businesses to find the optimal design cost trade-off at the feasibility study. If I would say simply, we just, you know, we automate building concepts and we do it at a fraction of cost. So if we go further, I just will explain a little bit which problem exists in that sphere. And yeah, so first of all, the main problem here is that, you know, creating and analyzing this concept design is a very lengthy process. So we have this architect, we have a cost consultant, we have a client, we have some project manager, and these people, they are working during this feasibility stage, trying to find the answer on a question like, are we going to build it or not? Like, does it cost our efforts or not? So, but with Creo Modular, we can solve this problem because we can create a building feasibility study in less than 20 minutes. So the second problem which we are trying to solve, this problem is connected with limitations, just because due to time constraints, just, you know, people don't have this like 1 month, 2 months for this feasibility study. This is why just a limited number of designs can be considered. So probably optimal scheme cannot be found. And this is why where Creo can help people, because using generative design, we can produce like, you know, up to 50 different design options for your site in less than 1 minute. So we can produce like a 500 different options in a few minutes. So yeah, the next problem connected with cost, because feasibility study is always about trying. It's always about trying. So actually architects, they probably can generate like 5, 10 different building schemes or different configurations. And it's always like a, you know, and at the end of this stage, only one building model will be chosen for the next iteration. And it makes previous building models like useless, and your time which you spend on these models, it's also like you know, it's like just really difficult to understand like how. And just because of, you know, just because time of such people like a designers or engineers, it costs pretty much. This is why Creo can help them just boost productivity for very highly paid professionals. And this is how we can like lower cost per feasibility study. So the next problem is about flexibility, because as you know, it's really difficult to change something. If architect create a model and after that you ask just to change like a unit mix or to change facades or something like that, okay, it always takes 2 weeks or 1 week, or, you know, or at least 5 days, I don't know. But just because in Creo modular, the main our point that we wanna architects use like a real objects, and like from the day one, we don't want people to use a windows or modules which will be simply exchanged during the construction phase. We say, okay, we should use modules, let's say modules, 3D volumetric modules from the beginning, and that will allow us to have a skin in the game from day one, because, you know, it's a real objects. We have a physical twin of those objects somewhere at manufacturer, and this is why we can increase this, first of all, skin in the game for architects and cost consultancies, and secondly, we can increase like flexibility, because we can easily change unit mixes, like building block heights, different unit, like, you know, facades, etc. I mean, we can just change it in 1 second. And also the last problem that we saw, that we see, it's about collaboration. So different platforms, let's say architects, they can work in Revit, cost consultancies will work in Excel spreadsheet, and all these people will talk with each other, like, you know, through emails, through some PDFs, docs, which is not really good. And this is why we want to build, and we actually built cloud-based platform, which is accessible by all stakeholders. And this is how we can, like, you know, improve this, fix this problem. So after that, just a few words about our value proposition, and I just will explain a little bit how feasibility study looks like, and where we can, you know, where we can get really benefits. For example, right now, if you see here to the left, like a side of my screen, you will be able to see like a lot of different brief information, which usually used like an input for feasibility study. Okay, we need a building somewhere here. This is our construction site. So we need like more than 5 residential units per core. We need amenity space more than 1,000 meters. We need GFA more than 75,000 square meters, etc., etc. It's like a set of numbers. And look, we have this layout, we have these modules. What can I build? So this is the main question during this stage, because this question lead to answer, will it be profitable to us for us to build it or not? So how it looks like right now. All this data come to architects and cost consultants. Architects are responsible for producing some kind of a model or floor plans and elevations, and cost consultants, they simply estimate this model. And for example, if architects, they simply build a model just like in one week about like, okay, this is our model, and after that it comes to cost consultancies, and they started to estimate this model. And, you know, when it, for example, they estimated it, and it looks like this model will cost like, you know, £3 million more than we have. And after that, cost consultancies, they write like recommendations to architects to change, let's say, glass to solid ratio or wall to floor ratio, or some other parts of your building to make this building more viable for a client. And this loop, it can be like really, you know, it can go through this, like a loop through this circle, like a few times, 4 or 5 times. And they use right now, let's say, Autodesk Revit or another software plus Microsoft Excel. And this is how in 2 weeks they can get like a massing options, feasibility sketch, and cost appraisal. So, but with Creo, we can merge them together. They can work together. So architect can easily, you know, just like a producer conceptual building model. He, you know, architect can produce hundreds of different designs, you know, at the 10 minutes, and they can sit together, and cost consultant will set up like a cost model for this building. And after that, like, you know, any changes will be immediately updated, and you know, it will take just 1 day, even with a very, very long coffee breaks. So I mean, it's really easy to build a conceptual model at a fraction of a cost. So, and yeah, actually that's it about presentation. I just don't want to spend more time on it. I will just quickly show you how it works. And yeah, I just assume that hackathon is about technical stuff. This is why I will show a little bit more about product and about technology and algorithms. So I just will go to our product, and we'll do a quick demo how it works. So let's create a new project. A new project. Let's call it like demo AEC Hackathon. Yeah, something like that. So next step, as soon as I did it, they appeared on the map. Here we can simply find suitable site for us. Let's say I want to build somewhere here. Yeah. Yeah, and just what I need to do, I just simply need to draw my site. And here we have 2 modes how to generate this building. But just before I draw my site, I want to explain a little bit about like you know, about stuff which should be done before our client go to the application. It's just a very simple scheme about how it works, because, you know, as I explained a little bit before, like we work with 3D volumetric modules, and each our client usually has their own 3D volumetric modules. This is why we need to upload them to our system. We need to digitize them. After that, we will launch our mathematician algorithm, which will generate, like, you know, a lot of possible building blocks, like thousands building blocks, take into account all those modules which we get from the beginning. After that, we can together sit, analyze them, and rank, and put them, integrate them with our platform. Of course, if user wanna, he can create like these blocks like by own, but we just wanted to prepare our platform a little bit to make sure that it will be a really good boost from the beginning. So when I draw my site, let's say here, I want to draw my site and I want to check how my generative mode works. So as soon as I draw site, system will start to propose for me some options. Yeah, like this one. I just do, yeah, let's say this one, or probably we can choose more complicated site like this one. Yeah, so I just simply draw my site to my system, propose for me some options. All these options is not only like a 2D options, is already massing schemes, and you know, it's just a few massing schemes for particular site with a different block heights. And why it's different, just because we take into account sunlight and daylight calculations. And of course you can work with that. All these blocks which you see, for example, this is block number 1, this is block number 2, is like a part of building which has own like a core configuration, corridor, and apartments layout around, apartments are around. So we can work with it. For example, we want to change the approach in accordance with which our site divided in a few zones. For example, if you see these red lines, it's like a zones for our site. Because this site is quite huge, we divided it. And for example, if I will change it to another algorithm, I will get like another decision for this particular site. Or I will change it to this algorithm, I will get another decision. If I will return back, I can, after that, as soon as I choose this like a site dividing algorithm, I can go deeper and I can manage all my parameters. My scheme will be changed, And also, if I'm not happy with the scheme, I can manually drag and drop these points, and my system will generate something for you. For me, also, if I don't like, for example, this building, I can say, okay, I don't like this building, let's exclude this, because here I have a flooding zones or something like that. Also, for example, I want to merge some zones. So we tried here, we tried to combine like a generative design plus some manual stuff, just because we know that architects, they wanted to do a lot of things manually. So this is why, for example, I will choose this zone, and I will simply combine them. And system will give me option with the merge zones. Also, so actually, this is our parameters which user can control to produce a different scheme. I mean, there are pretty many parameters, like you can change rotation, you can change like street widths, you can change alignment, you can change offset between buildings, so you can set it a bit. But if you're really tired with those parameters, you can simply press this button that generate options for me, please. Our system will start to generate different options for you. And also, what is really funny here is that, you know, all these options, they have a matrix to control, like gross floor area ratio, vertical sun component, direct sun, etc. And you can easily like go through these options, and you can choose like option which you like. And also, if you want to filter it a bit, you can do it. For example, you want to see just the options with floor area ratio more than 4 or more than 5. So you can simply do something like that. Okay, show me just options more than 3. You will see this option. So show me something with gross floor area more than, let's say, 72K, something like that. So you can actually set it. Yeah, you will see this option. If you like it, you can press apply and you can replace it. And you can press this button and you can click next step, and all your buildings will be calculated in 5 minutes. But okay, let's launch it just for fun. And after that, I will show you another mode for creating building footprint. Another
already,
mode
folks, in an effort of fairness to all those presenting, we're going to have to keep moving forward.
Okay, so how much time we have?
We have about a little bit less than 15 minutes before the stream cuts off.
Okay, I need the 5 minutes more to finish my presentation. Just I will do it very quickly. Okay, I've heard just about from 10 to 20 minutes. Okay, I just will do it quickly. Okay, promote is about yeah. Okay, if you go to, just want to show you a promote. So we generate all these blocks, and in the promote you can draw your site, and you will be able to work with already predefined blocks which we created on the previous step. So you will be able to put some blocks on your site like this one. I mean, it's already predefined blocks with all possible like unit mixes inside. You can choose another block, you can connect those blocks in a different ways, like this one. If you don't like those predefined blocks, you can create your own block. I mean, it's quite detailed. At the same time, we want it we don't want to cut like possibilities for architects, so we can put your apartments which created within your modules. This stuff, it's quite parametric, so you can actually change a lot. Yeah, and yeah, okay, I just stop it from here, and I just will show you how already completed project look like. So let me go back. For example, here, this project that we launched a few minutes ago, as you see, just one building is already calculated. Yeah, it's just screenshot is not here yet, but okay, let's wait a bit, and I will show you how it will look at the end of the day. So this is building. This is like a multi-building project is already calculated. I can go into 3D mode and I can see my federated model. So as you see here, it's quite detailed model. So actually, all these models have like a floor plans. So it's like a real BIM models. So you can change it. You can fly it around. You can do different cross sections, etc., etc. But as soon as you go deeper to building one, let's say, or to this building, let's go to this building. Here we will be able to see a floor plan, and if we go to this floor plan, just you know, you can go to this block, and you can see, okay, my unit mix is like a 59 one bedroom, 156 two bedroom apartments. I want to change it, so you can go to stories, and you are able to choose like all possible unit mixes for this particular footprint. Yeah, actually, yeah, this is how it works, and you can change your unit mixes. Also, if I go back, and I will go back to my architectural 3D model, just will show you how it's combined. As I explained before, we use like 3D volumetric components, which you can see like here. So I can actually choose this component just to show you how it looks like. So I can do a cross section. I mean, it can be any level of details. You can work with them. All these components in pretty well thought out. All they are stacked very well vertically. So all risers connected with each other, and all the stuff. Also, let's say you want to see just a volumetric stuff without basement, ground floor. You can choose only modules. You can see your mixes. You can play with it. Also, if your modules have a structural model, you also will be able to see it. Like this is a structural model. You can see these cages. You can go inside. I mean, you can do whatever you need here in a 3D model. So yeah, and what is really funniest thing here, that as soon as you're, for example, you have a building and you change this like a unit mixes on the different floors. Each time you create a new version of a building, and if your modular system is well thought out and it's well organized, you can actually create like different versions of your building, and you can do it quite quickly. And also you can create like a traditional frame for the same for modular building. If you go to this frame, you will be able to see like reinforced concrete structures. You can even, just for fun, you can see like a reinforcement. I mean, it's, yeah. So it can be quite detailed. It's up to our client, because we have a lot of algorithms which can work in the different ways, in different directions. And also I would like to show you our analytics board, because as soon as you create this conceptual model, you already have a real schedule summary, unit mix summary, elemental summary. You already have a cost. So actually we use, for example, here NRM breakdown structure. And we can go to core walls, we can see concrete reinforcement, formwork. All this quantity is connected automatically with all these categories and subcategories. What our clients need to do, they just need to put their rates here. And of course, here we have a modular cost, which connected with our 3D volumetric modules. And also we have cost for a traditional part of the building, like a basement or ground floor. So yeah, you can work with this like a cost model. It's quite flexible, because here you can connection to all parameters from your model. So actually you can create like a new parameter, for example, here, like a building footprint area, facade area, NIA, GIA, etc., etc. So you can create a new parameter, and you can create a new category for your cost model. Yeah. Also, yeah, just a sec. Yeah. Also, you are able to create a report quite quickly about your building. Let me show you how it can look like. So if you need to present your building, you can create a report. I don't know. Like a feasibility report. Just one sec, just will show you quickly how it works. Yeah, so let's choose building one. Let's go to reports. Yeah, let's create a report. Here you can put some text. I mean, if you wanna, you can put some 3D models. Let's put architectural model here. Let's put a floor plan. For example, here I want to put this block here. I'll add it here. So it's like a new kind of report. It's not about PDF more. It's just like you will be able to share this URL with anybody from your project. You will be able to put any charts here, like a module mix summary. Here probably you want to see pie of a cost summary. And yeah, you can even set like let's say you can put some stuff with a map here, like a code from a map about location. I don't know, like if you go quickly to Google Maps, if you find a place somewhere, yeah, in London, we put this guy here. So we will see this 3D stuff. We can simply share this stuff, yeah. And we can add it here, and we will be able to show it here. And so you can simply share this report with your client or with your colleagues and discuss it here. And yeah, actually that's it. Okay, let's stop my product presentation and let's speak about questions. Any questions about our crazy algorithms? how it works?